call me Peder if you want to speak English with me. Peder Bacher, and I'm also here working here at DTU Compute, like Peder is, and I'm teaching at the Fridays Introduction to Statistics for diploma engineers. So so we do the complete same parallel material as with you in 2402. Okay, but let's get started. Today is lecture number 6 on two sample comparisons. So let's see what that is about. We will have an example which we will follow throughout the lecture. And then we will repeat hypothesis testing, the steps in hypothesis testing, and what you need to know about that. We'll repeat that. Then we go into the two-sample t-test, and we'll also show you how to calculate confidence intervals, and also something called the paired setup, which is really simple once you see what it is. And then the last things, of course, like last time, you ended up with checking the normal assumption, and we also need to do that here when we have two samples. All right. So let's see what today, basically, what we can do is illustrated with this example. So let's say we have some nutrition study, and we want to find out whether the nurses in one hospital, we want to find out something about their energy use and compare it with nurses at another hospital. So it might be that things are situated differently in the two hospitals, so the nurses have to walk more or something like that. Anyway, we're able to measure their energy use in megajoule. I'm not totally sure whether it's the average over a month or something, or it's just a day. Anyhow, we have these two samples, and that's the point today. Last time you had just one sample, but now we have two samples from two different groups. We measure the same thing, and they also have to be independent. Later in the course, we'll come back to independence and what that is about. But now we have these two, and we want to compare them. The hypothesis that we can set up now regarding the mean, so you could say the real average or the average of the populations, but the mean, if we want to compare the mean of energy use for nurses at hospital A to energy use for nurses at hospital B, then we can set up this hypothesis where we say the null hypothesis is that the means are equal. So there's no difference. That's our null hypothesis. Okay? In this example, so what we will need to do is calculate the sample mean, so the average of each of the two samples, and also the sample standard deviations of each of them. And then we will use them in a formula to compare whether, to calculate whether, given that the null hypothesis is true, how likely is it to observe this data? And what we will compare, you can say, is that in the data, the sample means, the difference was 2, around 2, and we state the hypothesis, could it be that the population average, you could say, or the mean, that difference is 0 when we observe this. And what we need to take into account is also the sample deviation of each sample, but we'll come back to that. So what we can do now, we'll learn today, is calculate a p-value for this hypothesis, and then also a confidence interval for the difference. So from the observed difference plus minus some value, we can get a confidence interval. Yeah. So that's what we're going to learn how to calculate today. But first, we will